Imagine our entire Milky Way galaxy, hundreds of billions of stars, shrunk down to the size of Earth. On this scale, our radio signals have traveled just 4 millimeters from our planet. Yet in this cosmic ocean, we hear nothing but silence. No signals, no evidence of intelligent life, not a whisper. This deafening silence is what we call the Fermi Paradox, and it's one of the most profound mysteries in science. Where is everybody? It all started with physicist Enrico Fermi in 1950. During lunch with colleagues, he suddenly asked, "Where are they?" He wasn't talking about a missing party guest. He was pondering why we found no evidence of alien civilizations. His logic was compelling. Our galaxy contains up to 400 billion stars. Recent discoveries suggest as many as 40 billion Earth-sized planets orbit in habitable zones just in our galaxy alone. The universe has existed for 13.8 billion years, ample time for civilizations to arise and spread throughout the stars. Even if intelligent life emerges on only 1 in a billion planets, there should still be thousands of civilizations in our galaxy. Yet when we look out into the cosmos, silence. Complete silence. This is the great silence that forms the heart of the Fermi Paradox. To understand how strange this is, imagine searching for treasure in a vast desert, where mathematicians assure you millions of treasure chests are buried. You search extensively, but find nothing. Wouldn't you question your understanding of the situation? The ingredients for life, carbon, hydrogen, oxygen, are abundant throughout the universe. We've found organic molecules in space and amino acids in meteorites. Water, once thought rare, appears common throughout our solar system. The cosmic kitchen is fully stocked. So where are all the chefs? We've been actively searching for signals since 1960. SETI programs have scanned thousands of star systems. We've sent probes throughout our solar system and examined Mars with rovers. Our telescopes analyze distant exoplanets. Yet we found no conclusive evidence of life beyond Earth. Scientists have proposed many solutions to this cosmic puzzle. Let's explore the most compelling ones. Theory 1, the rare Earth hypothesis. Why Earth may be uniquely special in the cosmos. Perhaps complex life requires an incredibly precise set of conditions. Earth may be extraordinarily special, a perfect storm of life-enabling factors. A stable star without excessive flares or radiation bursts. Our sun provides consistent energy without sterilizing its planets. A planet positioned precisely in the Goldilocks zone, not too close and not too far, allowing water to exist in liquid form on the surface. A large moon stabilizing our planet's axial tilt, preventing chaotic wobbling and providing the stable seasons needed for complex life. A robust magnetic field, shielding us from deadly solar radiation, protecting our atmosphere and surface from particles that would otherwise make life impossible. Giant planets like Jupiter serving as cosmic shields, capturing or deflecting countless asteroids and comets that might otherwise impact Earth. Active plate tectonics continuously recycling carbon. Earth's natural thermostat maintaining stable climate conditions over billions of years. Maybe winning this cosmic lottery is so improbable that Earth is truly special, perhaps even unique. While microbial life might be common, the jump to complex organisms could be exceedingly rare. Theory 2. The Great Filter, the nearly insurmountable barrier to advanced civilization. This explanation suggests that somewhere on the path from simple cells to galaxy-spanning civilization lies an almost insurmountable barrier, a great filter that almost no species can pass. This filter could be in our past. Perhaps the emergence of life itself is extremely improbable. Maybe the evolution of intelligence or the development of technology are incredibly rare steps. Or more terrifyingly, the filter could be ahead of us. Climate change, nuclear weapons, artificial intelligence, engineered pandemics, any of these could be the filter that civilizations rarely survive. Perhaps technological species invariably destroy themselves shortly after developing advanced technology. The terrifying question, have we humans already passed this filter, or is it still looming ahead? Theory 3, the zoo hypothesis. Why advanced aliens might be watching us from afar. Perhaps advanced civilizations are intentionally avoiding contact. They might be studying us from afar, like zoologists observing wildlife. Maybe there's a galactic agreement to leave emerging civilizations alone until they reach a certain developmental milestone. We might be under a cosmic quarantine, Earth as a planetary wildlife preserve in a galaxy of advanced beings. They could be monitoring our development, waiting for us to mature enough to join the galactic community. This theory suggests the skies could be filled with carefully disguised observers. Perhaps UFO sightings throughout history have been brief glimpses of this cosmic surveillance. Theory 4. Beyond recognition. Civilizations that have evolved past biological existence. What if advanced civilizations evolve beyond biology into forms we can't comprehend? They might upload their consciousness into virtual realms or transform into energy-based beings. Such post-biological entities might communicate in ways completely undetectable to us. They could exist in dimensions we haven't discovered yet, or operate on timescales so vast that what we perceive as a millennium would be like a microsecond to them. Their technology might be, as Arthur C. Clarke noted, indistinguishable from magic to us. It would be like ants trying to detect human internet communications. The signals are all around them, but they lack the capability to perceive them. Theory 5. The simulation hypothesis. Our universe as a computer program. Perhaps the most mind-bending explanation. What if our entire universe is a simulated reality? If we're living in an advanced civilization's computer program, alien life might simply not be part of the simulation's parameters. This theory, popularized by philosopher Nick Bostrom, suggests that any civilization advanced enough would eventually create simulated realities indistinguishable from the real universe. Statistically, if this is possible, we probably live in one. In this scenario, the Fermi Paradox is easily explained. The programmers didn't include other technological civilizations in our particular simulation. Theory 6. We are first, humanity as the pioneer species in a young universe. Sometimes the simplest explanation is the correct one. Maybe we're the first. The universe is young, only about 13.8 billion years old. Complex life on Earth took about 4 billion years to evolve intelligence. The first generation of stars didn't contain enough heavy elements to form rocky planets. Someone has to be first. Perhaps humanity is the pioneer species that will eventually spread consciousness throughout the stars. If true, we bear an enormous responsibility as the universe's first torchbearers of advanced intelligence. This theory is both thrilling and sobering. It means the future of intelligent life in our galaxy and perhaps the universe rests entirely on our shoulders. Our search continues to evolve. Project Breakthrough Listen is conducting the most comprehensive sweep of the radio spectrum ever attempted, scanning millions of stars for artificial signals. The James Webb Space Telescope can analyze the atmospheres of distant exoplanets for biosignatures, chemical evidence of life. Future missions will explore the moons of Jupiter and Saturn, where subsurface oceans might harbor life. Some scientists are looking beyond conventional approaches. They're searching for technosignatures, evidence of megastructures like Dyson spheres that advanced civilizations might build, or looking for laser communications, yet our cosmic reach remains limited. If our galaxy were the size of the United States, our radio broadcast would have reached an area roughly the size of Central Park. We've barely begun to explore. The Fermi Paradox isn't just an academic puzzle, it cuts to the heart of our existence. If we're alone, we carry an incredible responsibility to preserve and spread consciousness. We might be the universe's only chance to understand itself. If we're not alone, an extraordinary journey of discovery awaits us. Contact with another intelligent species would be the most transformative event in human history. Either way, the answer will profoundly shape our destiny. As we stand at the threshold of becoming a multiplanetary species with missions to Mars on the horizon, the question becomes even more pressing. As Carl Sagan said, the universe is a pretty big place. If it's just us, seems like an awful waste of space. So what do you think? Are we cosmic castaways on an isolated island of consciousness? Or is the universe teeming with civilizations we haven't yet detected? Is the great filter behind us or still ahead? The search continues, and each new discovery brings us closer to answering Fermi's profound question. The truth awaits among the stars, and the quest to find it might be humanity's greatest adventure. If you're fascinated by cosmic mysteries like the Fermi Paradox, hit subscribe and join me on future explorations of our universe's greatest puzzles. Next time, we'll venture to Earth-like planets to discover what it would take for humans to survive. Perhaps the first step in our journey to answer Fermi's question ourselves. Until then, keep looking up. The answers are out there, somewhere.